We've already been practicing with circles in class, but let me go ahead and review a few with you. First of all, it's nice to know that there are 360 degrees in a circle. You're expected to know that. You might see this. I'm not 100% sure if you're going to see the radians. We'll find out. Circumference is 2 pi r. That's always good to know. Area is pi r squared. You better know that one. In fact, I wouldn't be surprised if you saw a circle like that. Surface area, not so sure if you're going to see that. It's 4 pi r squared. Volume is 4/3 pi r cubed. Not sure you're going to see that. We'll see. All right. So the central angle, I've seen some problems like this in some practice books, so I changed it up here. The central angle in the circle below is 90 degrees, so that means this is 90 degrees right there. That's the central angle, the angle that starts in the center of the circle. And it's subtended by an arc, which means there's an arc that covers it, all right, which is 2 pi inches pi. How many inches long is the radius of the circle? Well, one of the easy ways to figure this out, if this is 2 pi, how far is it around the rest of the circle? So, whole circle, what would that be? Hopefully you can figure out, oh, that's 8 pi. Why? You take this times 4, because there are 4 of those pieces around your circle. And there are 4 90-degree angles if I were to slice this up, right? So the circumference is 8 pi. So I'll write the circumference formula. 8 pi, substitute here, that's the circumference, and then figure out what the radius needs to be. Hopefully it's pretty obvious. What do I need that number need to be? I hope you see it's 4. 4 inches. If a circle with center -2, -3 is tangent to the y-axis in the standard xy coordinate plane, what is the area of the circle? So what does it mean to be tangent? I'm going to go ahead and draw it here on the side. All right. And the center is at -2, -3. Right? All you see is these nice grid lines. So that would be right about here. It's tangent to the y-axis, so that's the one it touches. It's going to just go right here and barely touch it, which means it's going to come up here and be roughly here. So if I drew a beautiful circle, which I didn't, that's it. And the radius will be this distance, which is 2. What's the area? The area is pi r squared. Pi times 2 squared, or 4 pi. Voila. And it would probably, if I had units, units squared, because it's area. They probably won't be that picky on units for you for your TSI. If the radius of a circle is 5 and the radian subtended angle measures pi over 4, what is the length of the arc subtending the central? So first of all, the important thing to do, that you may or may not have radians. So you have to know there are 2 pi radians around a whole circle. All right. And if I did the whole circle with a radius of 5, then circumference would be 2 times pi times 5, or 10 pi. The whole way around would be 10 pi. Well, what is pi over 4? How big a piece of the circle is that? Well, there's 2 pi for one whole circle, right? So all the way around is 2 pi. If I do half a circle, that's just 1 pi. If I do a quarter of a circle, that's pi over 2. Do you see that? So that's a fourth. This is a half. This is a whole. Let's try one more time. If I do a little bit there, an eighth of a circle, I get over 4. So they just want an eighth of a piece. So the arc length will be 1/8 of 10 pi, which is hopefully 5 pi over 4. You could say 1.2 pi, 1.25 pi. That's your answer. Okay? I'm not sure how much radians you're really going to see. Alright, here's a cool thing. This is a track, and the radius is, well, what's the radius for this circle if this is half a circle, right? Hopefully you're figuring out it's 25. So if you look at the pieces here, you got piece A, piece B, piece C, and piece D. P, C, and D, when you put them together, if it's drawn to scale, makes a whole circle. So I can just do one circumference, 2 pi r, and then these two pieces, plus 200, plus 200. Well, r is 25, so it's 2 times pi times 25, and hopefully you see that. 25 times 2 is 50 pi, and you're done. That's your answer. An observatory dome is hemispherical in shape with a radius of 18 meters, and is built using 12 equal sections, and it's a half of a sphere. Create a formula to describe the surface area of one section. So surface area total is going to, oh, and notice it didn't ask for an answer, it just wants a formula. Well, if it's a hemisphere, that's half of a sphere. And if we're just doing one section, that's a 1/12 of a section. What is the formula for surface area? You're going to do 4 pi r squared, right? And you could do some simplifying. For example, you could say, oh, there's 3. You would get 1/6 times pi times 18 squared, and you would be pretty much done. When you multiplied everything out, if you got it further, you could say 4 pi. How did I know that? I did 1/6 times 18 times 18. I changed that to a 3. And I left the pi there. 3 times 18 I knew was 54. So that's how I did that with the calculator. The volume would be a real bear, honestly. So the volume is 4/3 pi r cubed. And I just wanted to, oh, and it's a half of it. Why is it a half of it? Well, it's only half of a sphere. Why aren't I doing a 1/12? Because I said of the entire observatory dome. All right. So this becomes 2/3 times pi times 18 cubed, which is really just a total mess. And I'm not going to mess with it. All right?